Do you know about it or no?
No.
Yeah, I need to remember the name.
This is right though, right? This and this.
I got the same thing. Mine's just like horizontal because I used
Yeah.
S1. Uh,
Unless right.
unless this is different though. Let me see this. Let me see what this one is.
He got S0. Oh, and then C.
So that one's correct. The photo S1 prime S0C.
Okay, and then the second one is
S
S0.
S1 prime S0.
S0, and then C.
He got C prime. No, he got
Oh,
C
C
prime
prime
T.
T.
The T is
Oh,
true.
bro, I gotta know if this is correct.
It might be different for this given slide. Oh no, dude! For this one it works.
Yeah.
It doesn't matter what we choose in the top and bottom, right?
No.
Okay.
Right, so let me try.
Did you get that?
Because A2 is S1, here is S1,
CD,
S0,
S1,
C.
S0.
Can fill in this truth table.
And then C is.
We're right.
Is
We already know that's not his though, because he has 4 variables in one
Zero,
solution.
1, 0
That doesn't have
makes
4
equals
variables in a solution ever.
1, which is here. And all others are zeros. Okay, now let's build D0.
I think he's wrong, honestly.
such
He
that
did ask
D0
what was he wrong, but no one corrected him.
S1 prime, S0, C.
Should we ask him in chat?
That means when S1 is 0, S0 is 1, C is 1, D0
We can always
becomes
private message him, so no one can see.
you have to just. There's no way, bro. I'm not sure.
the answer for this
Unless it's specific for this question. He's in question 2, and he redrew that.
Yeah, so simply copy what you have from this.
I think he got it from N1 right here, but are they not the same? Maybe they are. Oh no, they're not the same. He's using a different variable.
Oh.
He uses T instead of toe. I thought it was abbreviated, but I think it's actually a fundamental variable.
Dude, we're on a whole different.
I know. That's what I'm
Then
saying.
the next question,
Wasting our
the
time,
field is
man.
blank.
Fuck it. We gotta record it.
These
This
blanks.
is.
Yeah.
So can anybody
Report's
tell
past
me
30 minutes.
whether
Yeah.
this is a 0
Or what are you recording on?
or 1?
33
Is it a
3.9.
1?
No,
or
what
0?
software?
QuickTime player.
So
I think it's
Shimam
just Magus.
answers this is 1.
Dude, how I found it, bro.
Why do you think so?
There's so much size. There's so much going
The
on.
answer, the short answer is
But why did he not?
0.
So he got that from
It should
this.
not be-
So he said
yeah,
S1
so,
prime.
Like James' answer, they should be 0 because there's no intervention at all during its implementation. So what that means is S1 represents S1
That makes
prime,
sense.
S0,
You just look what
C
goes into
prime.
the AND gates for N1 or whatever and find out what it is. It's super easy. N1 is like word.
This AND gate is split into two different parts. So what you obtain, D1 is actually located at this point, and there is no any flip-flop at all. So you do not need flip-flop for D1. And for D0, which means like exactly at this point, this is D0. Do we have any flip-flop here? No. So the answer for
Can you
these two
do you know the
blanks
logic
for
expression or
ups
no?
is 0 and 0.
He has it written down right here.
All right.
Is it
So
there or
then
no?
let's
No.
try
I did.
CLBB
I gotta eat
now,
this
such
first.
that our final objective is to obtain N1 from the CLBB's left-hand side. So N1 now can be represented as not a function of S1, S0, CT. Now you gotta make this N1 expression as a function of D1, D0, and T, which is D1, T, or D0. So now let me map this A2, A1, A0. So what is A2? A2 is O0, and O0 is connected to M1. So M1 is E1. Okay, then what is A1? A1 is O1, and O1 is connected to M0, and M0 is D0. And then A0 gotta be, now we have two options because O1, O already connected. So either we need 1O or 1-1. So which one could be the right answer for this very last blank? Yeah, Shibam, you got a correct answer. So the answer is a 1-0 because we want to utilize T, and 1-1 does not have anything here. So the answer for this blank or switch matrix is 1-0. Okay, so now we have all the pieces required to make N1. And now you need to make sure D1 comes first, D0 is next, and T is a very last variable. So let me write down here again D1, D0, T, and make truth table as usual. Now, what we need to have is whether D1 is 1, T is 1. D1, 1 here. Or if D0 is 1, then we have N1, and if N1 equals 1, 1, 1, 1, 0, 0, 0. So this seems to be correct answer, but indeed there is there is a better answer. Why don't you think about where we can locate X, the dot pairs can be located among these one of the or several of these eight blanks. Yeah, great job, Shibam. So D1 equals 1, D0 equals 1. I mean, simultaneous ones for D1 and D0 is not going to happen because if you look at the CLBA, the combinations you can obtain is 0 and 0, 1 and 0, 0 and 1, but 1 and 1 never occur. So that's why we do not need to really care about when D1 equals 1, D0 equals 1, that is impossible to happen. So that's why the best answer for these CLBB's left hand side is O0111O1XX. So
I'm kind of keeping up now.
Huh?
Kind of keeping up. I said. Basically, what you missed was you have this truth table, right?
Mhm.
And you have to draw out what D1 and D0 are, right? The output. So you have S1, S0, and C are given, right? So you put down, the four zeros, four ones, 2 0 2 1 combination, 0 1 0 1. Then you define what D1 and D0 are. D1 is going to be the AND gate,
Okay,
the
so we're
first
almost
AND gate of
there.
N1,
So what is the
and
answer for
N0
the
and D0
last
is going to be the second AND gate of
box?
N1. I'm not completely sure why, not gonna lie,
One,
but I think
correct.
it's because they're focusing on
Because
N1.
now
That's why
this
I'm not sure.
D1 of
And so you fill out
CLDP
the truth table for
represents
D0 and
this
D1, right?
point,
Or D1, D0.
Mm-hmm.
Then what you do is you
D1
put
of
D1,
CLDP.
D0, and T as like the input. So you put the
And this
combination of four zeros and
is
four ones and whatever,
being
and you put the
fed
output for
into
N1
the
this
state
time.
register. That
And
means flip-flop is there.
once
And then
you
this
find out
flip-flop
the output for
converts this
N1,
N1
you look back and
into
you're like, okay,
S1.
D1 and
So you
D0
see
never
N1
happen
is
at the same
there after
time, right?
going through
So
this
technically,
flip-flop.
in the input for
It
D1 and
becomes
D0, you don't need to
S1 and
account
it
for
makes
whenever D1 and D0 are
the
both 1.
Mm-hmm.
So
part of
you can put them as
percentile.
don't cares. So N1, the
Yeah,
bottom
so
two
that's how
rows of
you
N1 are don't
approach this
cares.
question.
Now the switch matrix. Oh, and then you put the N1 as
Yeah,
in
one
the second memory
question from the
block.
chat I received
Because this memory block contains
was
D1 and D0 here, obviously. And this one contains N1. That
on the
that's why you
yeah
solve
Shima
for
asked
D1,
on the
D0, and
exam,
M1
will
right
you
here.
still be able to get the lookup table
So you
question
just gotta make
right
sure you
even
put in
if
the
you
inputs
had
first,
some mistake
then
in
the
your
outputs of the first
HLSM
memory
truth table?
block, and then the inputs
That's a good
again
question.
with the
So I
outputs of
don't
this
want you
one,
to
and then the output of this memory block.
make
Yeah.
And you don't need to use all the
sequentially
columns,
affecting your
obviously, it looks
mistake all
like,
the way to
because
the
this
end of
column
your
isn't
question.
used.
So I intentionally detoured this chains of a mistake, so to say. So you don't need to worry about. So if you even if you make mistake from HLSM, you're going to be fine. So
Oh,
what I'm
what?
saying is you're going to be given uh, that is associated with this FPJ lookup table problem. The next question I got, Akita, how do you know what to assign to the switch matrix in the blanks?
So who asked me
Nikita,
that?
are you
These are
still
private
not clear
messages.
on how to connect the switch matrix?
Something about if you get the HLSM wrong, you can still get the truth table
Okay.
right.
How?
Yeah,
On the
I'm
lookup table, you still get the
curious.
lookup table right if you get the truth table wrong. It looks like maybe I don't know. That'd be huge. But how'd they even do that? I guess the corresponds to truth table, I guess.
Okay, so N1 as a function of a D1 D0 is obtained. And now we need to figure out the order of D1 D0. Otherwise, your answer is going to be totally messed up. And what you obtain is going to not going to be representing what you want. So it's very important to figure out what is A2, what is A1, and what is A0. And you already have the connection for A2 and A1. So A2 is O0, and O0 is connected to where?
And
M1.
one. Yeah.
So M1 is represented by O1, M2 is represented by 10, M3 is represented by 11. So because you have O1 at O0, A2 is equal to M1, and M1 is equal to E1. Likewise, A1 is connected to O1, and O1 is connected to OO, meaning M0. So A1 is equal to M0, and M0 is equal to D0. And lastly, A0 gotta be representing T. So that's why the switch matrix need to be 1, 0. By such, we can have the we can know the order of the D1, D0, and T, and then your answer 001101XX becomes the correct answer that represents this combinational logic.
Do you wanna? While I export the in the video, I'm just gonna post it on YouTube.
Okay,
So unless
other
the video also
questions?
Okay.
do you, while I do that,
Stefan
do you
said,
want to
I'm
ask
a
any of
little
our homework
confused
questions
with
we're
some
gonna
notation
Oh
in the
yeah, we're gonna ask
table.
it.
Did
while I
we
work on this
say
one?
D1 and D0
My brain is
twice?
so tired, man.
Yeah, like this shit sucks.
I'm trying to focus.
Yeah.
I'm gonna fall asleep.
Yeah, so D1
Do you want to
here and D1 in the another column, that
Done?
refers to
I
the
don't
same
know.
D1. But in
I mean,
order
like, do you have it
to
on you?
Yeah.
for you to come up with this N1's
The device,
expression,
and not gonna lie.
you gotta come up. You better need to write down this equation. Yeah, sometimes you guys, some of you good at manual arithmetic, but that is typically what I recommend.
Thank you.
So even though okay, so
Sleep.
in short, the left part of this truth table is representing CLBA. The right hand side represents the CLBB. Nathan said, can you explain how you got the equation N1, D1, and T or D0? Okay, so N1 is here. S1 prime S0 C prime T or S1 prime S0 C. And because the question asks you to fill in the left-hand side table of a CLBA with the portion of the logic function from part A that includes a C prime. So this term, the first term has the variable C prime. So that's why I follow the suggestion from the question, and S1 prime, S0, C prime is redefined as D1, and likewise S1 prime, S0, C is defined as D0. So that's how you reduce this row equation of the a row form into high-level hierarchical sort of abstracted form of N1 that is function of a D1, D0, and T. Trenton asked, why is X better than the value your expression gives even if it will never occur? Yeah, this is the reason why this X is the better answer is it has a larger degree of freedom. So what that means is it doesn't really matter whether you program this 1 1 or 0 0 or 1 0 0 1. So you have a larger degree of freedom if you write down here don't cares. If you
It
write down
doesn't
just
matter
one,
then.
then this is a very
Specific case.
narrowed one of the
So
answers.
I'm trying to
But
wrap my head
yeah,
around
that
the
still
source
works.
matrix,
That still
right?
works. But
So
the
what you did
best
was
answer is
first.
you
Oh, can you zoom in?
point
Nice.
out
That's awesome.
these guys are don't cares.
Why can't I? Whatever. He basically put down 0 1
Danny
1
asked,
0 1
can you
1 0
show
0 for
again
the
how you
different
got the
lines.
1 or 0 for the multiplexers?
Oh wait, no, they're using a spinner right now. Nice.
Okay,
People are still
let me
confused.
erase this.
Oh, nice. This is perfect.
Oh, everything was gone.
Darn, I messed up my screen. You know.
Okay, so the short answer for Danny's question is the reason why the multiplexer has zeros here. Because E1 represents this point, E0 represents this point. So there is no flip-flops needed here. That's why we don't really need this. That's why we need a multiplexer controlling the zeros so that these flip-flops are bypassed. Whereas this guy is 1 because what we obtained is N1, and which is going to
What
be
if flip-flops for again?
provided to
What if flip-flops
register.
for again? Now we can
So
delay
that's
stuff.
why this
But why
flip
is
flop,
that D1, D0?
once we want to utilize this flip
I
flop,
don't quote me on this, but I
and
think
then
we're focusing
finally
on
we
N1.
obtain S1.
think we're focused on we're
N1
implementing
going
logic for
to
N1.
flip flop
Oh, so
becomes
D1,
S1,
D0 is just the
I think
result.
we'll
like
get it
you
from
see here.
D1. From N1, I think. Yeah.
Trenton asks again, are don't cares less energy intensive to hold?
What does that even mean?
Don't cares less energy intensive.
Huh? He's confused too.
So don't cares. I would say there's
No,
there's
sometimes the
not
Trenton
like a
asks
don't cares in
questions. I feel like
FPGA program. So
Have you
what I
seen
mean
that
is
one video?
any combination is possible.
Can these three-dimensional data sets be used to
This is
create a more?
possible. This is
You ever seen?
possible. This is
no,
possible. This
but
is
I feel
possible.
like
It's a
honestly.
video of
Comparing
like a
to
kid just asking about
memory elements.
or tables, sorry. And
Oh
like a
no, I
basic
have
logic
seen that. I
test.
have seen that. Yes.
These be used
Francisco
to explain
asked,
more,
will we be
like
given the
more
D1
detailed
and D0
three-dimensional.
equations,
I think Trenton is totally
or
has to do that. 100% Trenton has to be
will
totally
we
involved.
have to get
Yeah.
those ourselves?
Does it even like
Does that even
exist?
matter, bro?
Does
So
it even
I'm
exist?
not gonna be
The way Professor said it was like that. It's even
explicitly giving you what the equation is, but some hints can be given, like D1 needs to include the term associated with C prime, and D0 needs to
but probably
include the
more energy
term
extensive
associated
or
with
whatever,
C.
huh?
So
Because don't care would mean a wider variety
Yeah,
would be
otherwise
acceptable.
there's gonna be
Maybe it'd be
many
less
different
because you don't need to worry
answers
about coding extra
possible.
stuff. I don't
So
know.
in order, grading is gonna be crazy. So I make some restriction in terms of how you define D1 and D0, but I'm not gonna be give you the answer. You need to follow the rule and come up with the answer.
Why do flip flops not matter again though?
Benjamin asked a question on the exam: will we be given the combinational logic? Yeah, this time, the final exam this time, I think I didn't give you this diagram. I What I remember is you're given a truth table, and then from truth table, you need to come up with the combinational logic equation. Okay,
Oh, they're
James
just memory
says,
blocks, huh?
if we make a
Flip flops
mistake,
memory
will
blocks.
our
Store
errors
data, but they
propagate
store it
through the rest
temporarily
of the
and then they pass it
problem,
on, so I can like
or
make
will we
delays and
take
stuff like
all
that.
points for the mistake and then follow our mistake through the
Oh,
rest of the
registers are really
problem?
made from flip
Yeah,
flops,
so as
right?
I answer the Shivam's question, so the error is not going to be propagating through your questions.
Yeah.
All
Really
right,
made from
then
flip
I
flops.
think no
I
more
need though.
questions.
So
Let's go
you don't need
forward.
a flip flop here because you're not storing anything. You're just doing it
So
right. You're
that
just doing
is
the and operation or.
that is worth 1555 points of your exam.
Gosh, that's a
crazy.
lie. That takes so long though. That does take a long time.
And again,
Are you
I'll
truthy with
give
never?
you a couple more
I think we got it. I'm not gonna lie,
candidates.
huh?
I mean, all I
I
need to get is
stop sharing
That first
and
one,
share
no,
another window.
second one.
the second, the 33%.
Oh, you need 32 to get an to pass.
Yeah, but obviously I'm not gonna try everything. Bro.
Why do you look so sad? What the heck?
Yeah, to sum of absolute differences, HLSM, and then lecture 19, finalize the HLSM portion. So we learned the data-dominated RTL design,
Oh my gosh, man, things stopped yet.
especially FIR filter, finite
Something
impulse
stopped of it.
response filter. Here, because we are utilizing concurrency, we just have two states, and then that necessitates many number of multipliers and adders. So you could convert this HLSM into this data path and controller, which is not given, right? So this is just HLSM. Still, this is HLSM. And data path is given, but FSM is not given. So this is something missing from lecture note, which you might want to practice.
Oh. Wait, what? Did you see that? The red blocks that he didn't fill in yet,
Yeah.
they're actually there though. There's stuff
Then
under. There's like a
lecture
white block on
21.
top of the
Oh,
actual
yeah.
So it
text.
seems like from lecture
I completely forgot about that.
previous lecture, which is 19. All done, but in lecture 21, you learned queues, and queues could be built as HLSM as well. So here, what you're seeing is data path for queue,
Oh,
but FSM
please,
controller is
Thomas.
not missing. It is
Please.
missing in the lecture notes. And you might be asked, okay, build a FSM for queue so that you come up with the
He's saying that
HLSM.
as if it's actually
So
there.
that could be one
He already
candidate.
built the exam, I'm pretty sure, so he knows that.
And then the concurrency. Your previous original sum of absolute difference circuit was fully, you know, sequential. And then you can build a concurrent version of SAD by deploying these multiple number of multipliers and subtractors and adders. So this is could be one example of a concurrent sum of absolute difference. The other example could be
Concurrent sum of
lecture
absolute difference.
22. Your FIR filter used to be sequential version or concurrent version. Original FIR filter you learned was concurrent version, which means you deploy many number of multipliers and adders, and then you execute everything in one step. When it comes to the by operator scheduling, you can come up with a smaller version, so which means a sequential version of FIR filter. Now you reduced the number of multipliers and adders, and you need to use a multiplexer as well. Um, so this is could be one example. So sum of Apple's difference, original version was the concurrent. This could be reduced, and FIR filter was initially concurrent version FIR filter. Uh, Smaller FIR filter can be made by
Oh, bro, I want to
you're
chase the after
expanding
class,
the
okay?
number of states.
I want to chase
So
the after class.
originally, the number of states
Illegal,
of
okay?
FIR filter concurrent
It's
version was
something
just
I
one
got.
state, and in one
I think I already
state
know
you
about it. What is
execute
it?
every multiplying and accumulation operation,
I
the
have one.
mag operation
You
at
have one?
once
But it's so fun.
due
Have you been
to
using it or no?
these multiple number of multipliers and adders. But when it comes to this sequential
Oh,
version,
you can, oh,
the
no,
smaller
I sure
FIR,
I've used it, bro.
you
Okay, they're saying
can
you can do
increase
that?
the number of
Insane.
states, but at
So
the same
I'm
time, you
in Mara
can
right now.
reduce the size of the circuit. Now you just
Device for
need
Bluetooth
just
connection.
one multiplier.
Yeah,
You just need
and the Bluetooth
one
connection
adder.
would be like James's AirPods.
Oh shit.
Yeah, someone accidentally connects to the AirPods.
It connects to you.
Yeah, I
That's
think
fine.
that's it for
I click
candidate
the button to run
applications.
the
So I
emulator,
think
and
so
basically
far
treats
I
it as a
talked to you
keyboard.
like
Runs my code in
five or
PowerShell.
so,
Bam.
more than
I can make
five,
it
less
download
than 10
whatever I want.
examples,
That's cool.
and you're
Yeah,
not
so
going
now
to be
I'm learning
surprised by
PowerShell
the
with that.
example
Let's
itself.
we should learn
Like
PowerShell again. It's fun.
2021, the old exam, it says some
There's so many
doomsday
documentations on it and
HLSM.
stuff too.
I don't like that example. So just stick to what you learn in the lecture note, and that could be something you already seen in this um, multiple lecture notes.